Hello everybody and welcome back. This is Alaa from VFX Arabia. Today I'm going to talk about the newly introduced flow operator inside Thinking Particle 6 and how we are going to use this operator not just for flow simulation but also to guide crowds like flocking birds or school of fishes. So let's get started. I'm going to provide you with this simple scene. So we have a bunch of particles following an object, a dummy, and we have this environment. No collision yet introduced. As you can see here, the setup, just position bar and put in a flow group. We have a scale, alignment, travel of the direction of travel. We have a follow for this node, the dummy, and an STD force with just turbulence. So the way to do it is very straightforward and fast. Let's bring down the amount of particles a bit, 200. Okay, so to do it, we just add 3 operators, which are the group. They're gonna hold the particles and tell them to be flow, and the boundary, which is the environment that they are gonna collide with, and finally we will add the solver, which will calculate everything. In the solver, first of all, let's increase the subsamples to and enable volume length, which gonna increase the accuracy, the interaction amongst the particle between each other. The boundary will hold the environment, cylinders in the plane, and finally the group will tell the solver would be the flow solver we added, and the group is the flow. And let's see the straightforward results. What are they gonna give us, those settings? Are they colliding? Nope, they are not. Have we missed anything here? Yeah, the boundary. We should add the flow solver in the boundary. Great, and now they are colliding. But they are sticking too much to the collision environment, so to solve this, we'll increase the bias intersect. Let's add, for example, a 10. And as you can see here, they are not sticking anymore, which is good. Let's change the smoothing radius. The smoothing radius is the distance between particles that they are gonna keep apart from each other. If we increase this number to, let's say, 15, they are gonna act like this. A big gap between them, which is good here. It's a nice result. Let's add some randomness to this. Random by particle and expose smoothing radius, and I use 15. Let's add something between 5 and 15. Looks nice. Increase the number of particles to 1000. Cool. I want to point out something about the beginning of this simulation. You notice that the particles or the fishes, like they exploded, spread apart, and this due to this setting is decompress. It's like the force that are repelling each of the particles. So if we brought this down to 0.1, this effect will be less pronounced. But it's a bit nice. Let's leave it around something 0.8. That's pretty much it. Let's take it now to the next level. Let's say we want to introduce a predator, a shark, that are going to attack those particles. This is our shark. If we added to the boundary, which is allow it to collide with a particle, it would collide perfectly, but we'll see a weird result. Okay, this doesn't look like a predator attacking a fish. Those fish should be panic and should like avoid this predator long time before it reach it. It's not like colliding, it's like running away. So to do this, we're not gonna use the boundary to solve this problem. We're gonna use something else. We'll use a force. And the way to do it, we're gonna add TP6 search and a node which will hold our predator and a force. Okay. The P-search will search around this position, the position of a node, amongst the flow particles, the fishes, in a radius of, let's say, 20. And the found particles ID, we're gonna fed to the force, and this force gonna repel it from this particle. So this is the position, the center of the force, our predator, and in a spherical force, it's gonna repel in all direction. Let's put something like 200 and test. The fishes are approaching, holding position for a while. The predator, nice. That's it. If we raised it to 500, okay, 500 and 30. Again, that looks cool. From another angle. Pretty much that's it. It was a quick tutorial, pretty easy to apply. I will wrap it up. We have a position-borne particles around 0.3 helper in the space. We have the dynamic set, this here, scale alignment, follow a dummy turbulence, some kind of wind. And this wind behavior, you'll change it according to your situation. This is like a fish. If it is a bird, you need a big scale of turbulence or a small scale, so you're free to do it. We have the flow group. Pay attention to the decompress and how apart are they between each other, and also the viscosity. Here in our situation we have a fish, so 0.3 is fine. If you needed birds, you might need to lower it down. And that's it for this tutorial. I hope you enjoy it, and see you next time. Thanks for watching. Bye bye.